All right, good morning, students. We are going to solve two-step equations, also called multi-step because it could be two or more. I believe all of it on this sheet is two. And the back side, we will have variables on both sides sometimes. Sometimes only one side, sometimes both sides. On the front side, the variable was only on one side or the other. Okay, so again, how do we solve all equations? Everybody should already have the answer. Oops. Solve all equations. Reverse PEMDAS. Written like this every time. You write any other way? No. I want it written like this every time. Okay. Now, before we apply reverse PEMDAS, for example, as we will do on the other side, or even, yeah, on the other side, you first combine all like terms. After you get all like terms together, then you apply reverse PEMDAS. Okay, so in it, when I say all like terms together, that means all like terms on the same side of the equal sign, combine like terms. Then we go ahead and apply reverse PEMDAS. Okay, here we go. So let's pick one. I'm going to pick one like 5 because it's, again, the new concept for some of you on how you solve and how I want it solved each and every time from here on out. This will make your life much easier, less chance for error in doing it this way. So I'm trying to solve for W. The first thing I ask myself, is the coefficient of W positive or negative? It is negative. That's why I'm going to move it to the other side to make it positive. So now it's positive 5W over here, which means the constant needs to go to the other side. So I need opposite of negative 37 is plus 37. So now I add 37 over here. 37 plus 8 is 45. Okay, now I apply reverse PEMDAS. The only thing is to divide by 5 on each side. And so W equals 9. I could check that by plugging back in. 8 minus 5 times 9 is 45. So 8 minus 45 is negative 37. You know your multiplication times tables. You can easily check that in your head. You don't have to write it on paper. I know middle school teachers, they make you write it all out, your checks. Okay, I expect you, if you know your times tables, you should be able to do it in your head. And you should be able to explain it to me in your head as well. Okay, so I picked that on purpose because it had the negative. So I'm moving it to the other side of the coefficient. Okay, now let's pick one with a fraction in it. Okay, decimal. Boom, I move it across. Now don't forget on decimals, when I subtract or add, I need to. Okay, so now let's go ahead and, oh, if I didn't finish it off because I got interrupted, so I paused the video. When you add or subtract decimals, you must line up the decimal. Remember, when I have negative 23, it's negative 23.0. Okay, so I'm subtracting that across, negative 2.6. I line up the decimals. Now, you have to remember here, I'm adding two negatives. Okay, you can see, if you want to think of subtracting one, they're the same signs. I'm adding the numbers together. That's 0.6 and 25, and I keep the same sign for adding and subtracting integers. They're the same signs. You add them, add the two numbers together, 23.0, 2.6, and keep the same sign. Okay, and then the last step would be divide by 3.2 on both sides. So now I have 3.2 into 25.6. Okay, of course the sign's negative because negative divided by positive is negative, so my final answer is going to be negative. You could just look like that and do a quick estimate. 3 goes into 25 8 times. So I put an 8 here. Not evenly. It goes, 8 times 3 is 24. It's as close as you can get to 25 without going over. And I do 8 times 2 is 16. Carry the 1. 8 times 3 is 24. And 25 I have the 1 decimal there, and so it goes in evenly and I get 0. Otherwise, you could, as you learned, move the decimal across right there, and then it's 8 also, doing it that way. All right, next. So anytime, don't forget, you can always pause these videos, rewind a little bit, either space out and hit play and do it again. Okay. All right, next one to look at is one with a fraction in it. Let's say 14. 2 ways of doing it. I can either leave the fraction and solve it with the fraction in it. Okay, but I'm going to show you a shortcut so you don't have to deal with fractions. We're going to clear the fractions out. That means I have to look at the denominator of each one of these. That's obviously 1. Dang it. What just happened there? Come on. 1. Where? Okay, right there. Okay. So over 1 over 1. And then this is a 3. What's the common denominator of 1, 1, and 3? It's 3. So I'm putting pressure on the entire equation, both sides. Multiply it by the 3 to get rid of that 3 in the denominator. So now I'm distributing. Negative 3 times negative 12 is negative 36. Equals 3 times 6 is 18. And I multiply here, the 3 cancels with this 3, so I'm left with just a 2, so plus 2y. Notice no fractions left. Hopefully your middle school teacher taught you this shortcut. Then I have to deal with fractions. Then I ask myself, is the coefficient positive or negative? Dang it! I didn't mean to hit that one. Okay. So let me put that back in there. Negative 36, 18 plus 2y. Okay, I meant to change the color right there. Okay, I now ask myself, is the coefficient of the y positive or negative? It is positive, so the y is staying on this side. So I'm subtracting across right there. So I subtract the 18 across. Notice they're both the same sign, so it keeps the same sign, and I add the numbers. 54 equals 2y. And last step, remember 2 times y, the opposite is division. So I divide by 2 on both sides. So I get y equals negative 27. Okay, and there's my answer. Notice I didn't have to deal with the fractions. I cleared them out by multiplying by the common denominator. Okay. Let's go ahead and do one of these. Find 3 consecutive odd integers whose sum is 117. So you have to know consecutive, one after the other. One after the other. Okay, so x plus 1, oops, plus 1, and x plus 2, oh no, odd, sorry. 3 consecutive integers would be x plus 1, and x plus 2. We're doing odd, so that means every 2, right? So x plus 2, and x plus 4. Remember, I add 2 more to get to the next odd number, right? Okay, whose sum, remember sum means the answer to an addition problem. So that means I add all these together. So I could take out those subtractions, the commas I meant. Let's just change the color and put pluses in here now instead. Okay, equals is 117. X plus x plus x, remember each one of these is 1x, coefficient is 1, so I have 3x plus 6 equals 117. Subtract the 6, remember reverse PEMDAS, add or subtract first. Reverse PEMDAS. So I add or subtract first. So I'm subtracting this 6 across. And now I have 3x equals 111. And now I'm up to multiply or divide. Divide by 3 on both sides. And I get x equals 3 goes in 11 3 times, the remainder of 2. Bring down the 1, 21. 3 goes in 21 7 times. Mental math. Okay, so the answer of x is 37, but it says find 3 consecutive odds. So I have to name all 3. The first one is x, 37. The next one is plus 2, 39. And the next one is plus 2 more for 41. Those are my 3 numbers, 37, 39, 41. Okay, backside. Like I said, if you ever need to pause to write it down, make notes on it, you just pause the video. You can always quickly rewind as well. All right, so here we're going to have to go ahead and move the variables to one side, the constants to the other side, then reverse PEMDAS. Okay? We always get the variables to one side and constants to the other. All right, first thing, trick one right here. Now, when I have it on both sides, okay, so let's do number one as well. I ask myself, which of these coefficients is smaller, 4 or 7? 4 is smaller. I always bring the smaller one to the bigger number side every time. So we're not, I don't care if your middle school teacher taught you to go to the left side or the right side. If they taught you, they probably say always to the left. Scratch that. We're not doing that. We're going to be smarter. Hopefully they've taught you this. Okay, you always bring the smaller coefficient to the larger, so you end up with a positive number every time. So I'm even though these are underlined, it's not a division. Okay, so I'm subtracting the 4x across, which means the constant has to go to the other side, so I'm subtracting, we'll change that color, subtracting the 12. 3x equals negative 21. X equals negative 7, divided by 3 on both sides. Okay, x equals negative 7. Okay, now here, notice no matter what side I go to, I'm going to get 0. My subtractor else, I get 0y equals 8 plus 3 is 11. I want you writing that 0y each time so you don't blow it. Now you ask yourself, when you see that 0y there, this means 0 times some number. 0 times some number. Remember, the variable is just a number, any number. 0 times some number equals 11. Can that ever happen? No, it cannot. So the answer is no solution. That's how you know when it's going to come out to be no solution. Write down that 0y, not just 0, okay? Because you can understand why it makes sense that it's no solution. Okay, in 5 and 6, you could do it one of two ways. You could just cross multiply. Remember, we have a proportion. If you're going to do that, okay, don't forget, anytime you have more than one term in a numerator denominator, you need to put parentheses around it. Each of those have 2 terms, so I need parentheses around to make sure I distribute it through, just so you know that. So how do we solve all proportions? You can always have one answer with that. How do we solve all proportions? I want to hear cross multiply and set equal to each other. That sets up the equation, and then of course reverse PEMDAS after that. Okay, so I'm going to cross multiply. 5 times 2r minus 3 equals 3 times 3 is 9. You often see middle school drawn that, the butterfly, they'll call it like this. So you can think of that. Just make sure you put the parentheses, because one of the things I'm going to ask, I don't see it, so what's this person missing? You tell me parentheses, and I'll say why, so you don't forget to distribute. That'd be the answer. Okay. Now, I could, this is 5 times the quantity, 2r minus 3. That is how you pronounce it. When you have a parentheses, say the quantity, and it was times. There's no sign in between. 5 times the quantity, 2r minus 3. So when you say the quantity, whatever you say next goes inside parentheses. That's why I said 5 times the quantity, 2r minus 3. Learn this so you say it correctly. All right, so opposite times is division. I could divide by 5 on both sides. That's one way of doing it, which you might not have been taught. But 9 divided by 5 does not go in evenly. So I'm not going to go ahead, I'm not going to go ahead and do that. I'm going to go ahead and distribute. So I get 10r minus 15 equals 9. Reverse PEMDAS now. Add or subtract first. So add the 15 across. 10r equals 24. Last step, divide by 10. And you should know when I divide by 10, you've been taught this over and over. When you divide by 10, all you do is move the decimal in one. So 24, so you normally be 24.0. I move the decimal to the left one, so it's 2.4. You should be able to do that in your head. Okay? So there's that one. Pause the video if you need to write it down. I just cleared out. Okay. Down here, again, we got to distribute multiple times first. Distribute there and there. Distribute here and here. I want to see those arrows so I know that you do not forget to distribute, because weak math students forget to distribute through the second one. They only do it the first one. So I want to see arrows on both. And you better therefore have two terms. At 2 arrows, I better have two different terms. 2a is one term, minus 16 is my second term. Then I have plus 7. Better have two terms. 5a plus 10, there's my two terms. Minus 3a minus 19. Now I combine like terms. When we say combine like terms, that means on each side of the equal sign. So I have 2a, I could put these two together. 7 minus 16 is negative 9. Remember, that's a smart way to say it. The positive on first. Here I have 5a minus 3a is 2a. And I have 10 minus 19 is negative 9. Okay. Now I ask myself, which side do I bring the variables to? Well, which one is smaller? They're neither. They're exactly the same, so it doesn't matter. So 2a minus 2a is 0a. Add that across, 9. Opposite of negative 9 is 9 minus 9 is 0. So I have 0 times a equals 0. What number can I plug in there that it will work? 0 times what number equals 0? Every single number works. 0 times anything is 0. So the answer is all real. Okay. That is sort of this double line right here, and then the R, that's the real symbol. You can use that also as just as all real. Other times people just write out real, all real. Okay. And if you want to say numbers, that's fine too, all real numbers. But that means all real numbers right there. Okay. Is that the second side or the first side? That was the second side. All right. So you've got everything you need to do your problems. Just note on 7 and 8, when I have decimals, I want to get rid of the decimals. You don't have to. You could subtract decimals and do it that way first. If you want to do that, that's fine. Or if I want to clear all the decimals, I see how many there are to the right. 1, 1, 1, and 1. So I only have to multiply by 10. However many numbers are to the right, I would take the biggest one. If one had 2 of them, one had 1, 1, and one had 3 decimals, so I'd multiply by 1,000. I take the most to the right of the decimal, multiply it by 10 times that with 1 plus however many zeros there are. So it'd be 1,000 in this case. Well, in this case, there's only 1 on each one to the right. So I'm multiply by 10. 1 plus only 1 0, because there's only 1 to the right. That then, remember, when I multiply any number by 10, it moves the decimal to the right, one spot. So now I get 4r minus 12 equals 3r plus 6. And then you can solve it from there. Okay, that gets rid of your decimal. So we'll stop there. 19 minutes.